Addressing an overcrowded neutral and ground bar requires careful attention to safety and proper technique. Before beginning any electrical work, safety must come first. Turn off the main breaker to the panel and wear appropriate safety gear, including gloves and eye protection. The following steps outline the process to resolve this issue. Firstly, inspect the existing neutral and ground bar for any signs of damage, loose connections, or overheating. Look for discoloration, melted insulation, or corrosion, which can indicate potential problems. Secondly, install an additional bar. Choose a sub-panel rated for the appropriate amperage and install a new neutral and ground bar in the sub-panel. Ensure the sub-panel is adequately sized for your needs to prevent future overcrowding. To connect the bars, start with the main panel. Remove the screws holding the neutral and ground wires to the existing bar. Bundle the neutral and ground wires together and attach them to the new bar using wire nuts. Ensure the wire nuts are appropriately sized for the number and gauge of wires you are connecting. Secure the new bar on the main panel, making sure it is properly grounded to the panel enclosure. Moving on to the sub-panel, remove the neutral and ground wires from the existing bar in the sub-panel. Bundle the wires from the main panel and the wires from the new sub-panel circuit. Attach the bundled wires to the new bar in the sub-panel using wire nuts, again ensuring correct sizing. Secure the new bar in the sub-panel, ensuring it is properly grounded to the panel enclosure. After making the connections, tighten all connections on both bars to ensure they are tight and secure. Loose connections can cause arcing, overheating, and potentially fire hazards. Use a screwdriver or nut driver to tighten the screws on the terminals, ensuring they are snug but not over-tightened, which could damage the wires or terminals. Next, bond the neutral and ground bars. Connect the neutral bar and ground bar in the sub-panel using a bonding screw or jumper. This bonding ensures that the neutral and ground are at the same potential, providing a safe and effective grounding path. Consult local electrical codes for specific requirements regarding bonding. It is very important to check the polarity. Use a multimeter to verify that all neutral wires are connected to the neutral bar and all ground wires are connected to the ground bar. Incorrect wiring can lead to dangerous conditions, including electrical shock or equipment damage. Set the multimeter to measure volts, alternating current volts AC, and check the voltage between the neutral and ground bars. It should read 0 volts or very close to 0 volts. Lastly, restore power. Turn on the main breaker to the main panel and check the voltage and operation of the sub-panel circuits. Use a multimeter to measure the voltage at various points in the sub-panel to ensure it is within the expected range, typically 120 volts or 240 volts, depending on the circuit. Test the operation of lights, outlets, and other devices connected to the sub-panel to verify they are working correctly. Here are some additional recommendations. Firstly, use a larger panel if possible to avoid overcrowding in the future. A larger panel provides more space for wires and connections, making it easier to organize and maintain the electrical system. Secondly, consider using a main lug panel, which has more space for wires than a main breaker panel. Main lug panels typically have more open space inside, allowing for easier wire management and connection. Thirdly, hire a qualified electrician to perform any electrical work to ensure proper installation and safety. The electrical work can be dangerous, and it is important to have the knowledge and experience to do it safely and correctly. A qualified electrician can ensure that the installation meets all applicable codes and standards. To elaborate further on safety, before starting any electrical work, always turn off the power at the main breaker. This prevents electrical shock and ensures your safety. Confirm the power is off by using a non-contact voltage tester or multimeter to test the wires you will be working with. Wear appropriate personal protective equipment, including insulated gloves and eye protection. This helps protect you from electrical shock and other hazards. Work in a well-lit area to ensure you can see clearly and avoid mistakes. Use insulated tools to prevent electrical shock. Never work on live circuits. If you are not comfortable working with electricity, hire a qualified electrician. Regarding inspecting the existing bar, look for signs of corrosion, which can indicate moisture or chemical exposure. Check for loose screws or connections, which can cause arcing and overheating. Examine the wires for frayed insulation, which can expose live wires and create a shock hazard. If you find any damage, repair it before proceeding. Replacing a damaged bar or wires may be necessary. When installing the additional bar, choose a bar that is compatible with your panel. Ensure the bar is rated for the amperage of the circuit. Mount the bar securely to the panel using screws or other appropriate hardware. Make sure the bar is properly grounded to the panel enclosure. When connecting the bars, use appropriately sized wire nuts or connectors. Ensure the wire nuts are properly tightened to prevent loose connections. Use a wire stripper to remove insulation from the wires before connecting them. Make sure the wires are fully inserted into the wire nuts. Check the connections to ensure they are secure and will not come loose. When tightening connections, use a torque screwdriver to tighten the screws to the proper torque specification. Over-tightening can damage the wires or terminals. Under-tightening can cause loose connections. Consult the manufacturer's instructions for the proper torque specification. After tightening the connections, double-check them to ensure they are secure. Regarding bonding neutral and ground, the bonding screw or jumper connects the neutral and ground bars together. This creates a single point of grounding for the electrical system. Bonding is required in sub-panels to ensure proper grounding. Consult local electrical codes for specific bonding requirements. When checking polarity, use a multimeter to verify the voltage between the neutral and ground bars. The voltage should be 0 volts or very close to 0 volts. If the voltage is higher than 0 volts, there may be a wiring problem. Check the voltage between the hot wire and the neutral bar. The voltage should be 120 volts or 240 volts, depending on the circuit. Check the voltage between the hot wire and the ground bar. The voltage should be 120 volts or 240 volts, depending on the circuit. If the voltages are not correct, there may be a wiring problem. Correct any wiring problems before restoring power. When restoring power, turn on the breakers one at a time to avoid overloading the system. Monitor the circuits for any signs of overheating or other problems. If you experience any problems, turn off the power immediately and consult a qualified electrician. Choosing a larger panel, consider the future needs of your electrical system. A larger panel provides more space for future circuits. Choose a panel that is rated for the maximum amperage you anticipate needing. Consider using a panel with more slots than you currently need to allow for future expansion. Regarding a main lug panel, main lug panels do not have a main breaker. Instead, they have lugs that connect directly to the service entrance conductors. Main lug panels are typically used for sub-panels or for applications where a main breaker is not required. Main lug panels often have more open space inside, making it easier to work with the wires. Hiring an electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. An electrician can ensure that the installation meets all applicable codes and standards. An electrician can troubleshoot any electrical problems you may be experiencing. An electrician can provide you with a certificate of inspection to verify that the work was done properly. To add more details about wire management, organize the wires neatly within the panel. Use cable ties or other means to bundle the wires together. This helps keep the panel organized and makes it easier to troubleshoot problems in the future. Avoid crossing wires over each other. This can create interference and make it difficult to trace wires. Label all the wires clearly. This makes it easier to identify the wires in the future. Use a wire labeling machine or write on the wires with a permanent marker. Keep a wiring diagram of the panel. This helps you understand how the panel is wired and makes it easier to troubleshoot problems. The wiring diagram should show the location of all the breakers, wires, and other components. Ensure that all unused breaker slots are covered with blank covers. This prevents accidental contact with live components. Regularly inspect the panel for any signs of damage or problems. Look for loose wires, corroded connections, or damaged components. If you find any problems, repair them immediately. Keep the panel clean and free of dust and debris. Dust and debris can accumulate on the components and cause them to overheat. Use a vacuum cleaner or brush to clean the panel regularly. Never spray water or other liquids in the panel. This can cause electrical shock or damage to the component. Keep flammable materials away from the panel. Flammable materials can ignite if there is an electrical problem. Ensure that the panel is properly ventilated. This helps prevent the components from overheating. Do not block the ventilation openings in the panel. In summary, addressing an overcrowded neutral and ground bar involves several key steps. Firstly, ensure safety by turning off the power and wearing protective gear. Secondly, inspect the existing bar for damage. Thirdly, install an additional bar, connecting the wires properly and tightening all connections. Fourthly, bond the neutral and ground bars. Fifthly, verify the polarity. Sixthly, restore power and check the circuits. Finally, consider recommendations like using a larger panel, a main lug panel, or hiring a qualified electrician. Following these steps will help you safely and effectively resolve an overcrowded neutral and ground bar, ensuring a reliable electrical system.